In the final video for section 2.1, we're going to do two things. First, we're going to figure out, given a graph, what is the equation of the parabola? And then also I'm going to spend a little bit more time at the end talking about finding the roots, and we're going to review the quadratic formula. So first of all, let's talk about, if we're given a graph, what we can do to find the equation. And let's just get straight into an example. So find the equation for the graph. And I'll say as well, in any form you like. So that means either vertex or general / standard form. Okay, so let's say my graph looks something like this. Let's go with 4 like that, and then we'll go over here. Actually, let's do this. So this is the 0.14, and then I'm not too concerned about the x-intercepts in this one, so let's just say it crosses somewhere in there. Okay. So this is not really drawn super well, clearly. But you have these points. So let's say you're given these points. Now, whenever I do a problem like this, I'm always quick to find the vertex, because vertex form is pretty easy to use in these sorts of examples. So I'm going to say f of x equals a times x minus 1 squared plus 4. Notice I'm given everything from the vertex except for the leading coefficient. I have h equals 1 and I have k equals 1. Now I just have to figure out a way to find the leading coefficient. In order to do that, I can pick either one of these points and plug those in. So notice this is x and this is y. So let's go ahead and just use this point. So y is 3, x is also 3 for this point. And so if I go ahead and start doing some manipulation here, let's do PEMDAS. So parentheses first, 2 squared, and then we have that plus 4. And so it's really a times 4, or 4a plus 4. So if I subtract that 4 over and then divide by 4, I should end up with negative 1/4 equaling my a. And so going back to my original equation, I now know that the equation of the graph is negative 1/4 x minus 1 squared plus 4. So when you're given the vertex, it's pretty straightforward. You can just plug that in for your h and your k. That's what we did to start with. And then to find a, you can pick either point. You should get the same answer with 3 and negative 1. But either way, you should get the same answer, and then we get our final answer there. So let's try another problem. Let's say you're given now some slightly different information. Let's say you have the x-intercepts in this case. So I'm not going to actually tell you what the vertex is, but I will give you the x-intercepts. And I'm also going to give you a y-intercept. Let's go ahead and say these are the x-intercepts. Looks like this. And let's say this is at negative 2. All right, so you have the points negative 1, 0, 3, 0, and then also 0, negative 2. Now I want to point out, if you were trying to do general form, you could actually get some of the information. You know that it's going to be ax squared plus bx minus 2. But getting that a and that b is really difficult just straight from the graph. It's hard to figure that out. You'd have to plug some points in, do a system of equations, which just doesn't sound good. So we're actually going to use a new format, which is called factored form. And factored form looks like this. You have a, and then we'll use some new letters. Let's use m and n. And in this case, m and n are actually your x-intercepts. But the important point in all of this is that a is still the same. A is still the leading coefficient, so that shows up in every single format. Let me remove this little string mark. Okay, so let's go ahead and use the factored form now. I know that my function will look something like this. F of x equals a, and then we have x minus -1, so x plus 1, and then x minus 3. And now to solve for a, we're going to use this point to solve for a. So in this case, y is going to be -2 and x is going to be 0. Let's go ahead and plug those in. -2 equals a. I'm going to have 0 plus 1 and 0 minus 3. So I have -2 equals a times 1 times -3 is just -3. So let's go ahead and divide both sides by -3. And I end up with a being 2/3. So now I can write my final equation. F of x is going to be 2/3 x plus 1 and then x minus 3. And since we said any form, we'll kind of use the instructions for the other example. We said any form, we can just leave it in factored form, and that's totally fine. So once again, what we did here is we found the x-intercepts first. We plugged those in, and then to solve for a, we just use any point on the graph. In this case, it happened to be the y-intercept, but it doesn't have to be the y-intercept. It could be any point you like. So that concludes finding the equation given a graph. I just want to finish off the lesson with talking a little bit more about finding roots. Let's go straight into an example here. Okay, so for the first one, we'll do, let's do p of x equals x squared plus 5x minus 24. Now, if you're asked to find the roots, what that means is you're finding the x-intercepts. So we'll set it equal to 0. This one is hopefully familiar. I'm starting off with a more familiar one. To factor, we need to add 8 and subtract 3 in order to get 24. So it's going to be x plus 8, x minus 3. So 8 times -3 is -24, and then 8 minus 3 is 5. So my roots in this case are -8 and 3, and that would be the answer. So just another example of factoring for you before we go into the next problem. Okay, so now let's do j of x. Oops. Try to color code here, use the black ink. So j of x equals 2x squared minus 4x plus 1. Okay, so let's go ahead and try to factor. 2 times 1 gives me 2. Are there two numbers that multiply to give me 2 and then add up to give me -4? No, there are not. So we would say this is not factorable. Sort of. So it's not factorable over the integers, meaning we can't find two integers that work. However, what we're going to do now is use the quadratic formula. So as a reminder, the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. To remember this, you might use the song that goes along with Pop Goes the Weasel, x equals -b plus or minus. You can look that up if you want, or you might just remember it. I will also give you this whenever you need to use it. Okay, so let's go ahead and fill that in. This is a formula you should have in your notes somewhere, but let's go ahead and fill this in. X equals -b, so that's -4 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. All right, let's kind of clean this up, get rid of some parentheses and square some things and subtract some things. So this is 4 plus or minus the square root. Well, 4 squared is 16 minus 4 times 2 times 1, and then all over 4. Continuing this along, 4 plus or minus the square root of 8 over 4. Now, it would be tempting to cancel those 4's out, but really we would have to distribute it to each. So what you could do is rewrite this as 4 over 4 plus or minus the square root of 8 over 4. And now you can write this as just 1. But actually, this is not quite simplified enough yet. There's one more step you'll see a lot of the times. That square root of 8, we're going to do something called reducing the radical. So 8 is the same as 4 times 2. I wrote it this way because 4 is a perfect square. So I can rewrite this as the square root of 4 times the square root of 2. And the square root of 4 is 2. And so I'm left with 2 root 2. Alternatively, a scientific calculator will usually do this for you. But this works in a lot of other examples. So as kind of an aside, if I said, I don't know, the square root of 18, this is 9 times 2. So this would be 3 root 2. Or if you did, I don't know, square root of 75, this is 25 times 3. So this would be 5 times the square root of 3. Okay, but going back to our problem here. So what we have now is that x equals 1 plus or minus 2 root 2 over 4. The 2 and the 4 simplify to 1 over 2. So my final answer would actually be 1 plus or minus the square root of 2 over 2. Those are my two x-intercepts. All right, so this is sort of the, if you're doing a standardized test or something, this is the standardized test version because this is technically the reduced form of the fraction. So a lot of folks will make you do it this way. However, I'm fine if you do a problem like this. I'm okay if you stop here. And I think Delta Math usually is as well, so you can stop there and call it good. But if you're taking an ACT or something like that, just know you might have to do this version down here. So be comfortable going back and forth between the two forms or typing it into the calculator to get the alternate forms. Okay, the final problem, I know this is going on a bit long. This last one will be pretty quick. Let's say I had you do, I'll pick another letter, L of x equals 2x squared plus x minus, let's do something like 8. Okay, so this one does not factor. Actually, I want to do plus 8. There we go. This one does not factor. So let's go ahead and use our quadratic formula. B is 1 here, negative 1 plus or minus the square root of 1 squared minus 4 times a times c, all over 2 times a. So we get negative 1 plus or minus the square root of 1 minus 64, all over 4, which is negative 1 plus or minus the square root of negative 63. Oh no. Square root of negative 63. You've probably seen imaginary numbers at some point. This is not a real number. We are currently sticking to real numbers. We will eventually talk more about imaginaries, but you would just in this case say no real roots or no real solution or something like that, and you would call that good. Okay, so that concludes section 2.1. Keep in mind this was about a month's worth of material that I boiled down to one day, so if something I did didn't quite make sense or you have forgotten something, please let me know during class and I will definitely help review that with you. I tried to make this more of a review than teaching a new topic, but if you've forgotten something, this could be very difficult to go through. So please let me know, but we'll go